And there it is, yeah, so I think that was my intro slide. This is the slide I already said, okay, we started with Tesla 300, more than 300,000 cars were recalled because of software problems, not updatable via over-the-air updates. I think there's also something you heard maybe about the cost for the delay of the Mustang Mach-E. Recalls over recalls, so last year we saw in the automotive field twice, recalled twice more vehicles than produced overall. And the root cause is, in our point of view, mainly the complexity of the system. As I mentioned, so several thousand parts, a lot of wires, a lot of electronical complexity, a lot of lines of code in the software, but also a lot of variants. For sure, the big number in there is maybe also included in the colors, but we have also a huge technical complexity, and it's growing. Our customers want to also make a more individualization into place for their customers, and this is also bringing down into the variants, into the technical variants. So the root cause, what did we change in the automotive industry the last years? And not just automotive, it's also seen in other industries. The complexity of the mechanics is going down. Yeah, we all know this, we have e-cars. But the software and the electronic complexity is going up because we want to perform more features, more functionality. You all explained this, it's going up. We see in the industry also more challenges. Why? Because in the software complexity and in software features, we need more transparency. Beforehand, in mechanical world, you've seen the effect, you can measure it, you can see it, you can feel it also in the production and after sales areas. In the software, that's not the case. If we compare also the functions of complexity in mechanical and software world, we also see that the complexity is growing much faster. Reason, sometimes I explain this very easy. You see you have, 3 different rims. This is something you see directly. If you have 3 different software modules, you are not always seeing it directly that you have installed maybe 1, 2, or 3. So this drives the complexity very high. You see where the dot is nearly today. Some customers of us are a little bit more than the left, and some more on the right. But we see in the first functions on platforms where you have over-the-air update capabilities for, I would say, not so crazy valuable functions. But this is something our customers are changing right now, so this is something you are changing and going more into a connected platform, software platform. We also saw all of this. And the dynamic of the curve will also lead that we are not able to solve the problem with more and more manpower. Like in the past, often when we had a project which had delays, we were able to solve it with more manpower. This is not possible in the future anymore. Yeah, also when you look in example from Porsche today, I don't know with the cycles if I can really see the same. We've seen in the industry a little bit more that we create them like in the V model requirements. So this is where then the transformation is happening from the sales department into the R&D divisions. And we have to define functions, sub-functions, different layers. I think this is already also doing sometimes, connecting this to a logical layer. So we have the architectural processes in there, the software and the electronic architectural processes. And then we have to bring this to the P layer and make it really concrete and real cars. Sometimes we're missing also in an overall picture for the communication, so the AXML for the overall vehicle is not existent. It makes it hard to really create test cases and ensuring that the function from customers are really living in these cars after we design it. When we're looking now into the connection between the electronics and software, I think this is sometimes a little bit missing in the presentations from today. we see it's just undividable. So the software in the car must live somewhere. For sure, we want to have the standardized, and we also want to have the VSSO and the ontologies we created in the Covesa and everywhere, and also Autosa, but this is sometimes not the reality. And we think we just have to bring the stuff together, really looking in the electronical and software world, because this is also reality like it's in the real cars. So this is why I'm saying the software only approach will never work. And yeah, we need a system approach and an overall visibility of this information for a system complexity problem. So now the sales process is starting. So when you want to have some drinks, then no. But what do? We bring in our customers the transparency, traceability of the overall system into place. We're not going to approach saying, okay, now we have to kick some suppliers, some software suppliers out of the game. We help our customers that they create their information model, which represents the information of the vehicles they are developing and selling to their customers. And this is what we call engineering intelligence network. It brings from the data layer information into place. This is a typical data-centric approach. And we can learn from the relations, which we take them, for example, out of the logical layer and bring it to the physics. So our product, what we sell is like a platform. We have a connection layer down. You've seen this in this picture. This is where we connect it to the huge systems of our customers. Often it's Siemens or vector tools, the typical players in the game, also sometimes their own systems, their own developed system, database-based systems of our customers. And this is what we bring in automatically into the engineering intelligence network. Building a graph, a knowledge graph, out of the information from mechanics, electronics, and software. And this is what we present in this knowledge graph. So usually the context, which is the base to learn on, is something we have in there. Based on this, we have a federation. So means we create an optimized views in an also open source format. It's via GraphQL, and these are optimized for the specific needs of our customers and users. We developed then the low-code functionality with Spread Studio around this to bring applications in some days in front of users and really having a sustainable ROI for them. One example, when you have this connection, you can say that you have an effect chain of your model series. This is something which you don't have to use only for engineering. This is something our customers use in their production area, in the prototype phase, also in the series, in the production area, and soon also in after sales areas, where they're analyzing based on the diagnosis results, having the effect chain, knowing what's the real root cause for a problem, for a communication problem a customer has in front of them. This brings lower variety cost, faster troubleshooting, and so on. And this is something we bring and really spreading the information from early areas in the engineering, upstream, downstream, in the chain to the after sales. We're mastering the variants, so talking about over-the updates. Some companies in the field are already doing this, some not. But when we want to update something, for sure every CEO from the automotive wants to do this because it's very high profitable revenue in there. But what's missing is you have to know what's your market when you want to bring a new function into the fleet. So it means you have to know in which kind of car does this function is able to perform in. And this is often missing. This is also why we see in the German automotive OEMs over-the-air functions which are just dependent from one ECU. So we are not seeing right now functions where several ECUs are involved. And this is what, as I said, we're better, mainly because the architecture is less complex and they have not so many variances. So it means the market for a new function is bigger in comparison to the Germans. And this is something we are just able to solve when we have the transparency, what's possible technically and what's not. So yeah, this is where we help in, bringing this transparency into place and showing the revenues in the after sales areas and yeah, helping our customers to knowing what's really happening. Understanding of an overall car was not needed in the past because we divided our whole organization in electronics, where software was somehow embedded in all of the suppliers here, solved in the end the game, and on the other hand the mechanical world with engines and so on. Yeah, we built cars around engines in the past. I also was not in my whole life in a startup as a founder. But yeah, so now is the time to speed up to understand really the overall system. And if you have interest in this, so we are here. Just contact us. And now I'm very open to your questions. We have 1 minute left.